to work out the sum of a series. Those series in A-level maths were typically geometric or arithmetic series, and some of them were expressed using sigma notation. In further mathematics, we've seen formulas for the sum from R is 1 to n of R or R squared or R cubed, which you can use to find the sum of the first n terms of a series whose rth term is a quadratic or a cubic polynomial. The standard series on the formula sheet. There's one other way that we can work out an expression for the sum of a series in further mathematics, and that's something called the method of differences. So the idea of the method of differences is you're trying to find the sum of the terms in a series. You write the terms in the series as the difference between related functions. And then when you write the terms out, you'll see most of the terms will cancel out, thus giving a formula. Now, this is best illustrated by means of doing an example. So here's example 1. I want to find an expression in terms of n for sigma r is 1 to n of ln of r plus 1 over r. Now, guys, when you're doing this, when you are doing the method of differences, it is always going to be useful to have the series we are trying to find the sum of expressed in sigma notation, and if necessary, expressed as a difference of two terms. So in this case, I can do that straight away. This is the same by laws of logs. Ln of r plus 1 over r is the same as the sum from r is 1 to n of ln of r plus 1 minus ln of r. Now, what I'm going to do next is so I've now written the formula we're trying to sum as the difference of two simpler functions, two related functions, the same formula, just different value r. What I'm going to do now is start writing out the series, and I'm always going to write down the first 2 or 3 terms and the last 2 or 3 terms to see what happens. So this means sum this series, starting at r is 1. When you put in r is 1, you get ln2 minus ln1. Then add, I'm going to do it underneath. When you stick in r is 2, r plus 1 is 3, so you get ln3 minus ln2. And I'll just do one more. When you sub in r is 3, you will get ln4 minus ln3. Dot, 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 dot. I'm also going to write down the final 2 terms. So I'm going to do the last term first of all, because that's a bit easier. The last term is when r is n. So you will get ln of n plus 1 minus ln of n. And the term before that will be when r is n minus 1, which means r plus 1 is n. So you'll get ln n minus ln of n minus 1. Now, what we can see is that lots of these terms will cancel out. For example, we've got a plus ln2 in the first row and a minus ln2 on the second row. Those will cancel out. I've got a plus ln3 and a minus ln3. Those will cancel out. This ln4 would cancel out. And if I carry on to the bottom, this plus ln n and minus ln n would cancel out, and this minus ln n minus 1 will go. Now, there's always some sort of pattern in terms of cancellation. However many terms you are left with at the top, there will be symmetrically terms on the other column on the bottom. So in this case, all we're left with is these 2 terms. So that's minus ln of 1 add on ln of n plus 1 at the bottom. And there you go. So that's the method of differences. We wrote the thing we're trying to sum as the difference between simpler terms. We wrote out the series. Loads of things will cancel out, and you just write down what you are left with. Now, in this particular case, we can simplify this slightly further because ln of 1 is 0. So therefore, this gives a formula of ln n plus 1 is my expression in terms of n for that. Is that okay? That's my first one, folks. Example of use of method of differences. Second example I'm going to go through is the following. We can use the method of differences to prove some of the standard results of summation which we met earlier in the course. In a minute, I'm going to prove this formula. The sum from r is 1 to n of r squared is a 6n, n plus 1, 2n plus 1. In order to do that, I'm going to use method of differences. And first of all, I'm going to use this bit of algebra here. So I want to show that r plus 1 in brackets cubed minus r cubed is 3r squared plus 3r plus 1. To do that, I will take the left-hand side of the bracket, left-hand side of the equations, the identity, sorry, and expand the brackets. So by doing a binomial expansion, or if you want, by just expanding, by writing 3 brackets down and times them together, r plus 1 cubed, the first term is r cubed, the second term is 3, choose 1, which is 3 times r squared multiplied by 1, so that's 3r squared. Plus 3, choose 2, which is 3 times r times 1 squared, so that's just 3r, add on 1 cubed, which is 1. And I've got to take away r cubed. So the r cubes cancel out, and I will get 3r squared plus 3r plus 1 as was required. So I've shown that the left-hand side is the same as the right-hand side. Now what I'm going to do is hence, i.e. using this, I'm going to prove this formula for the sum from r is 1 to n of r squared. Now how I'm going to do that is the following. I have got an identity, 2 expressions which are the same. So the sum of the terms generated by the left-hand side must be equal to the sum of the terms generated by the right-hand side. So what I know is that the sum from r is 1 to n of r plus 1 cubed minus r cubed is equal to the sum from r is 1 to n of 3r squared plus 3r plus 1. Now what I'm going to do is rewrite both of these. The left-hand side I'm going to simplify by using the method of differences. The right-hand side I'll expand later. So can I first of all deal with the left-hand side of this? Can I deal with this expression here? So the sum from r is 1 to n of r plus 1 cubed minus r cubed. I'm going to use my method of differences approach. Sub in r is 1, and you will get 2 cubed minus 1 cubed. Add, sub in r is 2, and you will get 3 cubed minus 2 cubed. Sub in r is 3, and you'll get 4 cubed minus 3 cubed, sorry. And you can see the cancellations can take place. Keep on going. If you sub in r is n, you will get n plus 1 cubed minus n cubed. If you sub in r is n minus 1, you'll get n cubed minus n minus 1 cubed. Now, loads of things will cancel out. They will cancel out. Those will cancel out. All of these will cancel out. So that will give me n plus 1 cubed minus 1 cubed. And 1 cubed is 1. That's all we're left with there. So what we now know is the following. That the sum from r is 1 to n of 3r squared plus 3r plus 1 must be equal to the sum on the other side, which is n plus 1 cubed minus 1. Now I'm looking for an expression for the sum from r is 1 to n of r squared. I'm allowed to quote the standard result for the sum from r is 1 to n of r, which is 1/2 n plus 1. So what I'm going to do now is expand the left-hand side. So I'll get 3 times the sum from r is 1 to n of r squared plus 3 times the sum from r is 1 to n of r plus the sum from r is 1 to n of 1, which is just 1 add 1 add 1 n times, which is n, is equal to n plus 1 cubed minus 1. Now, this is the thing we're looking for an expression for. So what I'm going to do now is replace the sum from r is 1 to n using the previous formula and then rearrange to make this the subject. So 3 times the sum from r is 1 to n of r squared plus that's 3 times 1/2, which is 3 over 2 n plus 1 plus n must be equal to n plus 1 cubed minus m. I'm now going to rearrange this equation to get that bit by itself. So I know 3 times the sum from r is 1 to n of r squared is equal to n plus 1 all cubed minus 1 minus 3 over 2 n plus 1 minus n. Now, guys, I want to put the right-hand side in a factorized form. Usually, I would try to do this by finding common factors, but because of this 1, there are no common factors. So all I can really do is expand the right-hand side and then try to refactorize. So if you expand n plus 1 cubed, you will get n cubed plus 3n squared plus 3n plus 1 minus 1. If you expand 3 over 2 n plus 1, you'll get minus 3 over 2 n squared minus 3 over 2 n, and then finally take away n. What I'm going to do now is collect together like terms. So the n cubed term is just n cubed. The n squared term, I've got 3n squared minus 3 over 2n squared, which is plus 3 over 2n squared. The n term, I've got 3n minus 3 over 2n minus n. So that's just going to give me plus a half n. And the plus and minus ones cancel out. I'm now going to factorize out my n. I'm also going to take out a factor of a half. So that gives me a half n into n squared plus, 2n squared plus 3n plus 1. Now, folks, that quadratic you can factorize as 1/2 n of 2n squared plus 3n plus 1 factors as n plus 1 times 2n plus 1. Now, we're nearly there, folks. This is the thing we're trying to find a formula for. I've got this extra factor of 3. If I divide by 3, which is times by a third, I will get the sum from r is 1 to n of r squared is 1/6 n plus 1 to n plus 1 as required. Last example for question 1, ladies and gentlemen, boys and girls. So here we are given a question which involves sigma notation. This can sometimes arise in this question. Part A is requiring you to do some algebra, and then part B wants you to find the sum of the series. Let's worry about part A first of all. So part A, I want to show that if f of r is r factorial, remember r factorial means r times by r minus 1 times by r minus 2 times by all the way down to 1, assuming r is a positive integer. I want to show that f of r plus 1 minus r f of r is given by r factorial. So what is it going to be? So f of r plus 1 minus f of r is the following expression. F of r, we know, is r factorial. F of r plus 1 means replace r with r plus 1, and that is r plus 1 factorial. Now, to write it in the form that's given, what I'm going to do is use the definition of a factorial to rewrite r plus 1 factorial. Here, I am multiplying together all of the integers from r plus 1 all the way down to 1. That's the same as doing r plus 1 times all of the integers from r down to 1. It's r plus 1 times r factorial minus r factorial. If I now expand that bracket, I will get r times r factorial plus r factorial minus r factorial. The plus or minus r factorials will cancel out, and that's the same as r times r factorial. Now, in part B, we are asked to hence find an expression in terms of n for the sum of this series. So what I'm going to do is, first of all, express this series in sigma notation, and then we'll see how the previous part can help us. So each of the terms that I am summing has the form a number, let's call it r, times the number factorial. So the series is the sum from r is 1 to n of r times r factorial. Because the first term in the series is r factorial when r is 1, then 2, then 3, the last term, which is when r is equal to n. Now, to find the series for this, it's not a standard polynomial or anything. I'm going to try to use the method of differences. I am now going to use part A. So this is the same as the sum from r is 1 to n of f of r plus 1 minus f of r, which means the sum from r is 1 to n of r plus 1 factorial minus r factorial. And that's a candidate for using the method of differences because it's been written as the difference of two more complicated, two simpler expressions. So now we start doing the summing bit. Sub in r is 1 and you'll get 2 factorial minus 1 factorial. R is 2, we get 3 factorial minus 2 factorial. Add r is 3, we get 4 factorial minus 3 factorial. Keep on going down. The last term is when r is n. It is n plus 1 factorial minus n factorial. The previous term is n factorial. Take away n minus 1 factorial. Loads of these will cancel out. I've got a plus or minus 2 factorial, a plus or minus 3 factorial, a plus or minus 4 factorial. Keep on going to the bottom. All you're left with is those two terms. So therefore, it is n plus 1 factorial minus 1 factorial, which is the same as n plus 1 factorial minus n is the expression that I'm looking for. Okay, folks, so that's it for lesson 1. You are now in a position where you can do exercise 1 to practice this.